everyone, welcome you back in my geography class. Today we will discuss on the topic of structure of the earth from the chapter interior of the earth of class 11. In our earlier videos we have discussed about the seismic waves, we have discussed about the P waves, the S waves, the L waves and also about the relic waves. We have also discussed about the shadow zones and about the types of earthquake. Now, let us know about the structure of the earth. In this chapter, we have discussed that there are some direct and indirect sources which provide us information about the interior of the earth. With the help of the information that has been obtained from direct and the indirect sources, we can conclude that the structure of the earth is layered. It is a layered structure in a spherical shell like an onion. All of us has seen an onion. Now when we are taking an example of an onion, when we cut down the onion, what we get? We get different layers that comes out of the onion, and this is the best example to illustrate the layered structure of the earth. Our earth also have different layers with different densities. Now in this video we will know about these layers of the earth. We will know about their composition, we will know about their characteristics or the properties, and we will know about their characteristics, and also we will know about the discontinuities that separate one layer from another. Now let us know that how these layers are formed. Now we know that earth was formed of different materials, and different materials have different density. That means some materials having higher densities and there were some materials which were having lower density. Now what happens when the earth cooled? The heavier materials, they sank to the center and the lighter materials rose up to the top. So we can say that as we move from the top towards the center of the earth, the density of the materials will vary. At the top we will get the materials which are of the lighter densities, and as we are moving from the top toward the center, the density is going on increasing, so the center will have the materials with the heavier densities. Now let us know about the three layers of the earth. The earth is divided into mainly three layers: crust, mantle and core. So the three layers of the earth are crust, mantle and core. This one is my crust, here is my mantle, and this one is my core. Now in this video we will use these words upper or outer, lower or inner. These layers of the earth, the crust, mantle, core, they are again subdivided into upper crust, lower crust, upper mantle, lower mantle, upper core and lower core. Or we can say that outer crust, outer mantle, inner mantle, and outer core and inner core. Now let us understand about the different layers of the earth one by one. First we will know about the crust, then we will know about the mantle, and then we will know about the core. So the first layer is the crust. Now crust is the outermost solid layer of the earth. So this is the crust, the solid outermost layer. Here we will find landforms, that means continents, oceans, we will find minerals, rocks, and this is the layer where we are living. So the outermost solid layer of the earth, where we will find ocean, continent, mineral, rock, and the layer on which we live is referred as the crust. Now this layer is brittle in nature. Now during the earthquake, this layer gets broken. Why? Because it is brittle in nature. Now the crust is divided into the continental crust, or we can say the upper crust and the oceanic crust, which is the lower crust. So here is the continental crust, and here we have the oceanic crust. Now the thickness of the crust varies under the oceanic and the continental crust. Now let us know what is the thickness of the crust. The thickness of the crust is 8 to 40 kilometer, and if you will talk about the oceanic crust, the thickness of the oceanic crust is 5 to 10 kilometer, and that of the continental crust, it is 30 kilometer. Now, so we can say that the thickness of the oceanic crust is 5 to 10 kilometer, whereas the continental crust is 30 kilometer. Now, the thickness of the continental crust will be more where? In the areas of mountains. Like in the areas of the Himalayan mountains, where it got a thickness of 70 kilometer. Now, how the mountains are formed? The mountains are formed due to the movement of two continent plates. When the two continental plates move towards each other, both have the same density of materials. And what happened due to the same density of materials? Now what will happen when both the plate will have same density of material? There will be a collision which led to the formation of mountains, like the Himalayan mountains, due to the folding process. So Himalayas is an example of a fold mountain. Now we will see that though the thickness of the continental crust is much more than the oceanic crust, but oceanic crust is much more heavier than the continental crust, and that is why we will see that the continents rest upon the oceans. Let us understand how it happens. Now already we have read about the three types of plate movements: the convergent plate movement, the divergent plate movement, and the transform plate movement. Now we will only know about the convergent plate movement. Now in the convergent plate movement, the movement of the plates are towards each other. Now the movements of the plates can be of continent and continent origin, can be of ocean and ocean origin, and can be of ocean and continent origin. Now what happens when there is movement of plates of both the continent origin? Now that will lead to formation of mountains, as we have just understood. Now what will happen when there will be a movement between an oceanic plate and a continental plate? Now what is an ocean? An ocean means a cavity which is filled up with water. It seems that its thickness, it's not much more, but it is very much denser because it is a cavity which gets filled up with water. So it got much higher density. Now what happens when two plates, one of which is of oceanic origin and the other one of its continent origin, will move towards each other? Now the oceanic plates, they are of much heavier materials. That means they are much more denser than the continent plates. So it will lead to a subduction. How it will happen? The continent plates, these are the lighter plates, and the oceanic plates are the denser plates. So what will happen when two plates will collide with each other? At that time, the heavier plate or the denser plate, it will move down, because we know there is always a tendency that the heavier materials, they sank down and the lighter materials rise up. So the heavier material, that means oceanic plates heavier, so it will sank down, and the lighter material, that means the continental plates, they will settle down or they will float above the oceanic plate. So we can say that the continental plates rest upon the oceanic. That means the continents rest upon the ocean. Now let us understand with the help of another diagram. This referred as the continental crust, which carries the continents. And this is the ocean floor. This is the ocean and this is the floor of the ocean. Now, as I told you that an ocean is a cavity filled up with water. So this is the ocean and this is the floor of the ocean. And the oceanic crust lies beneath the continental crust. So here is the oceanic crust. As we have understood it now that the continents being the lighter, they rest upon the ocean. That means the continental crust rests upon the oceanic crust. So this is the continental crust and this is the oceanic crust. This is also known as the upper crust and this is the lower crust. Now we understood that the continental crust is lighter, so we can say that it is lighter in density and the oceanic crust is heavier in density. Now as I told you that the continental crust is lighter, that means they are lighter in densities, and here the oceanic crust is heavier in density. In terms of density of continental crust, it is 2.7 gram per cubic centimeter, and in terms of the oceanic crust, the density is 3.0 gram per cubic centimeter. So you can see that the oceanic crust is much heavier than the continental crust. The minerals that mainly constitute the continental crust are the silicon and aluminium. So we call it as the Cl. And the minerals that constitute the oceanic crust, they are the silicon and magnesium, and we also call them as SEMA. So it has been said that Cl rests upon SEMA. That means the continental crust rests upon the oceanic crust, or we can say continents rest upon the ocean floor. Now, if we will talk about the rocks that are found in the continental crust, in the continental crust we will see that igneous and metamorphic rocks are found, or it contains the igneous or metamorphic rocks, the granite, and the oceanic crust contains basalt and ultra basic rocks. Now, as we have understood that the continental crust is of much lesser density and the oceanic crust is of much more density, that means it is heavier, that is 3.0 gram per cubic centimeter. Now, we will see that the continental crust, which is the upper crust, and the oceanic crust, which is the lower crust, is divided from each other by a discontinuity. Now, what do you mean by a discontinuity? A discontinuity means a zone which marks a boundary between different layers of the earth. So we can say that a discontinuity is a zone which marks a boundary between different layers of the earth. Here we will see the seismic waves that we have discussed in our earlier videos change their velocity. So the velocity of the seismic waves changes where? In the discontinuity. So the discontinuity that divides the upper crust from the lower crust is referred as, what does it referred as? It is referred as the Conrad discontinuity. So the discontinuity that separates the upper crust from the lower crust is the Conrad discontinuity. Now we will see that nearly 1% of the Earth's volume and 0.5% of the Earth's mass is made up of the crust. So nearly 1% of the Earth's volume and 0.5% of the Earth's mass is made up of the crust. Now, if we talk about the mean density of the materials that compose the Earth's crust, it is 3 gram per cubic centimeter. Now, let us move ahead to know the next layer of the Earth, that is mantle. So, the next layer is the mantle. Mantle is the layer beneath the Earth crust. So, beneath the crust, the layer that we find is the mantle. The thickness of mantle is 2900 kilometer. So the thickness of mantle is 2900 kilometer. Nearly 84% of the Earth's volume and 67% of the Earth's mass is made up of mantle. If we talk about the density of mantle, it is higher than the crust. It is 3.3 to 5.4 gram per cubic centimeter, and it is mostly made up of silicon and magnesium. Now, the discontinuity that separates the crust from the mantle is referred as the Mohs discontinuity or Mohorovic discontinuity. Mantle is the layer from where we can say that there is inverse change in temperature. At first, the rise in temperature is rapid. That means there is increase in temperature in a rapid manner. That is, for every 32 meter, there is a change of 1 degree Celsius in temperature. Now, while reaching in the upper 100 kilometers, the change in temperature is 12 degrees Celsius. That means 12 degrees Celsius for per kilometer. Now, after reaching 300 kilometer, it is 20 degrees Celsius per kilometer. So we can say that with depth, there is a variation in increase in temperature. As we are going more deeper, it is 10 degrees Celsius per kilometer. If we say that on average, with depth, how much is the increase in temperature? It is 25 degrees Celsius per kilometer on average. So mantle is the layer from where the temperature increases inversely. Now the mantle is divided into two layers, the upper mantle and the lower mantle. The upper mantle is also known as the asthenosphere, and the lower mantle is known as mesosphere. Now, the upper mantle or the asthenosphere is the weak layer. Mainly, if we will talk about the mantle is in a semi-molten state. Mostly, the upper mantle is solid. It is hot, it is solid, but it is malleable in the regions of tectonic activity. So what happens in the upper mantle? The upper mantle or the asthenosphere is the weak zone. Astheno means weak. So this is the weak zone which allows the molten rock to move upwards and to reach the crust. So the upper mantle, which is a plastic solid with varying densities, allow the convection current to flow the molten rocks to the crust, and this results in volcanic activities, earthquake, and also movement of the plates. So from the asthenosphere, the molten materials reaches the earth's crust, and it results in volcanic activities, earthquakes, and also the movement of the plates. Now, the upper mantle and the crust together forms the lithosphere. The upper mantle and the crust together forms the lithosphere, and they have a depth of 200 kilometers. So the upper mantle and crust forms the lithosphere, and lithosphere is broken into several tectonic plates, and the movement of these tectonic plates are initiated by these molten materials which exist in the asthenosphere, and these plates, they float on the asthenosphere. That means it floats on the mantle, right? So the upper mantle and crust together forms the lithosphere. Now let us know about the discontinuity that separates the upper mantle from the lower mantle. It is known as the Repetit discontinuity. So the discontinuity which separates the upper mantle from the lower mantle is a Repetit discontinuity. Now let us move ahead to know the next layer, that is the core. The next layer of the earth is the core. It is the innermost layer of the earth. Nearly 15% of the earth's volume and 32.5% of the earth's mass is composed of core. Now, in terms of density, the density of core is 9.5 to 14.5 gram per cubic centimeter. So the core is the layer with the highest density. Now the discontinuity that separates the core from the mantle is known as Gutenberg discontinuity. So the discontinuity that separates core from the mantle is a Gutenberg discontinuity. The density of the materials at the mantle core boundary is 5 gram per cubic centimeter. And when we come to the center, that means as we are coming to the interior of the earth, there the density of the materials is 13.5 gram per cubic centimeter. Now the core is again divided into the outer core and the inner core. Now the core is mainly composed of nickel and ferrous, and that is why we call it as a knife layer. As it is mainly composed of nickel and ferrous, it is called as a knife layer. Now, if we talk about the outer core is in liquid state. and the inner core is in solid state. Now the outer core is mainly made up of nickel and ferrous, and the inner core is mainly made up of ferrous, that means iron. So the outer core is made up of nickel and ferrous, and the inner core is made up of only ferrous. Now in terms of the thickness, the outer core have a thickness of 2300 kilometer and the inner core have a thickness of 1200 kilometer. So total the thickness of the core is 3500 kilometer. So the outer core has a thickness of 2300 kilometer and the inner core has a thickness of 1200 kilometer. Total the core have a thickness of 3500 kilometer. The core acts as the Earth's magnetism. As we have read about the magnetic field while reading about the indirect source of information, the magnetic field of the Earth is caused by the current of the electricity that flows in the molten core. Now let us know about the temperature of the core. The temperature in the outer core is 4000 degrees Celsius to 5000 degrees Celsius, and in the inner core it is 5000 degrees Celsius to 7000 degrees Celsius. The temperature of mantle is 1000 degrees Celsius to 3700 degrees Celsius. So you can well understand that with depth how the temperature is changing. Now the question that comes to your mind, that why the inner core is solid in nature whereas here the temperature is the highest, because not only temperature changes but pressure also changes, and here in the inner core there is huge pressure which does not allow the molten material to move as a liquid. That is why the inner core is solid in state. Now, the discontinuity that separates the outer core from the inner core is known as the Lehman discontinuity. So, the discontinuity that separates the outer core from the inner core is known as the Lehman discontinuity. So in this video, what we have learned about the structure of the earth. We have learned about crust, mantle and core in details, and also we have learned about the discontinuities that separates the crust from the mantle, the upper crust from the lower crust, the upper mantle from the lower mantle, the mantle from core and outer core from the inner core. So we have also learned about different discontinuities. I hope all of you understood it very well. You can go through the PDF which has been already provided in the description box, which will help you to understand this topic more clearly. If you have any problem or any suggestion, do comment in the comment box. If you like my video, do share it with your friends and don't forget to hit the like button. If you're new to my channel, do subscribe my channel and do hit the bell icon to get the further notification of my upcoming videos. Stay tuned. I will be back soon with the next topic on this chapter. Till then, take care and stay safe. Thank you.